All right, it says consider the sublimation of carbon dioxide dry ice is spontaneous under standard conditions. So we have CO2 solid going to CO2 as a gas. And we find that the delta G of this reaction is minus 18.7 kilojoules per mole, or minus 18700 joules per mole. So this is a negative value, which means that this is spontaneous at room temperature. We have a large increase in entropy, okay, because we're going from a solid to a gas. Presumably the delta H here is positive because we have a solid forming a gas, so we have to put heat energy in to get a solid to form into a gas. So it says, can this be made non-spontaneous at 500 degrees C by increasing the pressure of CO2 gas to 25 atmospheres above the solid? And this could be practically accomplished by putting it in a sturdy closed container. So this is a different type of non-standard conditions. So in this case, the delta G is going to be equal to the standard delta G plus RT ln Q. And Q is the non-standard conditions. Q is like K, but not at equilibrium. It's under non-standard conditions. In this case, Q is going to be in pressure units, and it's going to be the pressure of CO2 gas divided by, this is a solid, so it does not appear in there, over 1. So Q is actually going to be your 25.0 atmospheres because it's products over reactants, but in this case only the product is a gas, so there are no reactants. So now we can plug into this equation. Remember that your R is 8.314 joules per mole K for this question because we want it in joules. This means that our delta G naught also must be in joules. So our delta G under the non-standard conditions is your minus 18,700 joules per mole plus 8.314 joules per mole K times the temperature, 500 degrees C. We can't plug in 500 degrees C. We have to add 273 to that, so 773 K, 773 K times the ln of the Q, but in this case the Q is just 25.0. Sorry about that, I ran out of space. So the ln of Q is 25 because again it's only products, there's no reactant. Now I have to do the math. When we do the math, we find that the delta G is 2.00 times 10 to the third joules per mole, or 2 kilojoules per mole. All right, so under these very high temperature and high pressure situations, the delta G has become positive. So under these conditions, this is non-spontaneous anymore. So, spelled that wrong. All right, so this is non-spontaneous anymore because the delta G is positive. So we use this equation when we have non-standard conditions, which give us, pressures, in order to find Q, which is the current conditions.